Hello and welcome to PCMS Norata, and you're watching this video on valency of an element by Sonal Gupta. So friends, valency is a very important formula, or I would say the base of chemistry. You know, when you have to calculate the chemical formula for any substance such as say water, I would just take a simplest example. Water, you all know, is H2O. This actually shows how many atoms of each element are present in a molecule, or they tell us the proportion of the atoms of any element. This formula can actually be worked out using the concept of valency. Now, what is valency? The valency of an element, in simplest terms, I would say, is related to how many electrons are there in the outer shell. The concept of valency is actually based on the octet rule. So there's an octet rule which says that whatever is the last shell of an atom, it should have 8 electrons. Now when we say it should have 8 electrons in the outer shell, so every atom would fight to complete the octet, right? And in order to complete the octets, that is to have 8 electrons in the last shell, the atoms will, either donate their extra electrons to the other atoms, or they will accept electrons from the other atoms. So, and will they donate or will they accept electrons from the other atoms? It depends on the number of electrons in the last shell. So let's see how. So let's see here. Now atomic number of hydrogen is 1. So its configuration is just 1. So for hydrogen and helium, we just have a different rule, like because they already have just 2 electrons and 2 can be accommodated in the first shell maximum. So hydrogen is short of that 1 electron. So 1 is easy to donate also and easy to accept also. So the valency of hydrogen is plus minus 1. And for helium, the atomic number is 2. So it has only 1 shell, and that 2 is complete because it can accommodate a maximum of 2 electrons. So its configuration is 2, and its valency is 0 because it will not donate or accept because it is already complete. Now let's talk about lithium. So lithium, its atomic number is 3. So its configuration is 2, 1. Now this 1 electron is very easy to donate, and so that the 1 shell it is left with is complete in itself. So this becomes, we say its valency is plus 1, because the one which will donate electrons, it will acquire a positive charge. Similarly, beryllium, its atomic number is 4. So it has 2, 2. That means beryllium can easily donate these 2 electrons and be a stable shell with just 2 electrons as the outermost shell. So its valency is plus 2. And boron, its atomic number is 5. So it is 2, 3. 3 is a little difficult to donate, but it's really difficult to accept 5 electrons to make it 8. So it better gives off these 3 electrons. So its valency is plus 3. But now the scenario starts changing carbon onwards. Now carbon's atomic number is 6, and therefore its configuration is 2, 4. And 2, 4 means the outermost shell has 4 electrons. Now we say, according to the octet rule, your outermost shell should have 8 electrons. Now for carbon, either it can donate 4 electrons or it can accept 4 electrons. So based on that, its valency is plus minus 4. Plus because if it donates, and minus if it is accepting. What do you think about nitrogen? It's 7, so it will be 2, 5. It's really difficult to give off 5 electrons than to accept 3 electrons. So this will accept 3 electrons from any other positive element. So its valency would be minus 3. That's negative 3 because it is accepting the electrons and increasing the negative charge on it. Similarly, we go to oxygen, 8. So its configuration is 2, 6. It will quickly accept 2 electrons and complete its octet to become 2, 8. So its valency is minus 2. And for fluorine, it's 9. So it's 2, 7. It can quickly accept 1 electron and become a complete octet. So its valency is negative 1. And for neon, what do you think? It's 2, it's 10, so its configuration is 2, 8. And since it's already complete, its octet is complete, so its valency is 0, right? Now we can check similarly for sodium. The atomic number is 11, so its configuration, as we just discussed, was 2, 8, 1. Now it has that 1 electron in the outermost shell. So otherwise it has 3 shells, but it cannot have 7 electrons in the last shell to make a complete octet. But it has an easier option. It will give away this 1 electron to some other element and become 2, 8. So it becomes a sodium ion. So this has a valency of +1. So similarly, if you would carefully notice, so sodium, magnesium and aluminium, which have the 1, 2 or 3 electrons in the outermost shell, they can easily donate those 1, 2 and 3 electrons, and so their valencies are +1 for sodium, +2 for magnesium and +3 for aluminium. And on the other hand, if I talk about the negative elements, so if we look at just phosphorus, sulfur, chlorine and argon, so I have phosphorus as 15, which is 285. So what do you think? It's going to accept 3 electrons, so it's negative valency 3, -3. For sulfur, the atomic number is 16, so the configuration is 286. It will quickly accept 2 electrons to complete the octet and become -2. So chlorine, with the atomic number 17, its configuration is 287. Now you know that it will quickly accept 1 electron and become a chloride ion, and it can accept, so -1. And what about argon? Its atomic number is 18, so it's 2, 8 and 8, and the last shell is already complete again, so it's 8. In the octet rule, you just want 8 electrons in the last shell and it's already complete. So argon will not participate in any transfer of electrons. It will neither donate nor accept, so its valency is 0. So you can easily remember the concept of valency by just understanding that if there are just 1, 2 or 3 electrons in the last shell, if the electrons are 1, 2 and 3 in the last shell, then that is the valency. Then your valency is just +1, +2 and +3. And if you have the number of electrons as 4, 5, 6 or 7 in the last shell, right? The number of electrons in the last shell is 4, 5 and 6. So then your valency would be, for 4 it will be ±4 because it can either donate or accept. But for 5, 6, 7, they are short of 3, 2 and 1 respectively. So for 5 electrons in the last shell, you will have the valency as 3. That's 8 minus 3. And for 6, you'll have 8 minus 6. That's 2. So you have -2. And 8 minus 7 is 1. So this is how the valency can be calculated for any element based on the number of electrons in the last shell. I hope the concept of valency is clear, and it is definitely based on the electronic configuration and the octet rule to complete the octet, that's to have 8 electrons in the last shell. So every atom is fighting to have 8 electrons in the last shell, and so either they donate and make the shell with 8 electrons as their last shell, or they accept to complete their octet. So that's how valency can be determined. I hope that's clear to you. Follow us on Instagram and Facebook at PCMS Norata. Keep watching. Thank you.